Highest common factor, HCF. We are now already familiar with the concept of common factors. Now we shall use it to find out the highest common factor. Consider the numbers 12 and 15. Factors of 12 are 1, 2, 3, 4, 6 and 12. And factors of 15 are 1, 3, 5 and 15. Clearly the common factors of 12 and 15 are 1 and 3. From these, the highest common factor is 3. So we say that the highest common factor, or simply HCF of 12 and 15, is 3. Similarly, if we consider three numbers 8, 20 and 36, the factors of 8 are 1, 2, 4 and 8. The factors of 20 are 1, 2, 4, 5, 10 and 20. And the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. So what are the common factors? They are 1, 2 and 4. So the highest common factor or HCF of 8, 20 and 36 is 4. So the highest common factor, HCF, of two or more numbers is defined as the highest factor among the common factors of the numbers. It is also known as greatest common divisor, GCD. We can also find HCF of two or more numbers by using prime factorization. For example, consider the numbers 7, 14 and 35 and find out their prime factorization. Now we write these numbers as the product of their prime factors. So 7 is equal to 1 into 7, 14 is equal to 2 into 7 and 35 is equal to 5 into 7. Clearly 7 is the only number common to all the three numbers. So we have the HCF of 7, 14 and 35 as 7. Lowest common multiple, LCM. Let us consider these two numbers. We know that the first few multiples of 2 are 2, 4, 6, 8, 10, 12 and so on. The multiples of 3 are 3, 6, 9, 12, 15, 18 and so on. Clearly the common multiples are 6, 12, 18 and so on. Which is the lowest multiple among these? It is 6. So 6 is the common multiple of 2 and 3 and also the least one. So we say the lowest common multiple or LCM of 2 and 3 is 6. The lowest common multiple or simply LCM of two or more numbers is defined as the lowest or smallest multiple among the common multiples of the numbers. As in the case of HCF, we can also use prime factorization to find the LCM. Take the numbers 10, 15 and 25. We start by taking the smallest prime number, that is 2. Now we know that 2 divides 10, so we write 5 below 10. As 15 and 25 are not divisible by 2, so we leave 15 and 25 as it is. Now none of the numbers is divisible by 2. So we move to the next prime number, that is 3. Now only 15 is divisible by 3. So we write 5 below 15 and the rest of the numbers as it is. Again, now as no number is divisible by 3, so we move to 5. Clearly, 5 is divisible by all the three numbers. So we get 1, 1 and 5. Again dividing by 5, we get 1, 1 and 1. We got all ones, so this is where we stop. Now all the numbers on the left are the divisors that we used and their product is the LCM. So the LCM of 10, 15 and 25 is 2 into 3 into 5 into 5. Common factors and common multiples. Now let us find out the common factors of 6 and 18. The factors of 6 are 1, 2, 3 and 6. Also factors of 18 are 1, 2, 3, 6, 9 and 18. So we can see that the factors 1, 2, 3 and 6 are common to the two numbers. These numbers are called common factors of 6 and 18. So, common factors of a given set of numbers are the numbers which are common to the factors of those numbers. Similarly, we can find the common multiples of two numbers. Let us take the numbers 4 and 5. Now, multiples of 4 are 4, 8, 12, 16, 20 and so on. And multiples of 5 are 5, 10, 15, 20, 25 and so on. We find that 20 and 40 are common multiples of 4 and 5. Note that the list of common multiples goes on 60, 80, 100 and so on. So the common multiples of a given set of numbers are the numbers which are common to the multiples of all those numbers. Note that common factors are always finite in number, whereas common multiples are always infinite. Factor tree. Here we shall learn to factorize a number using a factor tree. Consider the number 90. Think of a factor pair of 90. Say 10 and 9. Again think of a factor of 10, that is 2 and 5. Now write the factors of 9, that is 3 and 3. We obtained a factor tree for 90. Also, the prime factorization of 90 is 2 into 3 into 3. Let us take another example. Consider the number 2460. Now we make a factor tree for it just as we made for 90 by breaking the number into its factors. We obtain the prime factorization of 2460 as 2 into 2 into 3 into 5 into 41. Factors and multiples of a number. Consider a group of 8 students, 4 boys and 4 girls. If we want to group them, here are the different ways. In one group, that is, a group of 8 students, total number of students equals to 1 into 8, which is equal to 8. In two groups of 4 students each, that is, all girls together and all boys together, total number of students equals to 2 into 4, which is equal to 8. In 4 groups of 2 students each, that is, a pair of a boy and a girl, total number of students equals to 4 into 2, which is equal to 8. From the above, we see that 8 can be written differently as a product of two numbers as 8 equals to 1 into 8, 8 equals to 2 into 4, 8 equals to 4 into 2. Clearly, we know that 1, 2, 4 and 8 are exact divisor of 8. Hence, we say that 1, 2, 4 and 8 are factors of 8. A factor of a number is an exact divisor of that number. Now consider the statement 2 into 3 equals to 6. Here, 2 and 3 are factors of 6, or we can say that 6 is the multiple of 2 and 3. Also, as 1 into 6 equals to 6, so 6 is a multiple of 1 and itself. Similarly, as 2 into 5 equals to 10, so we say that 10 is a multiple of 2 and 5. Hence we say that a number is a multiple of each of its factors. To find the multiples of a number, we simply look at its table. For example, for multiples of 5, we write the table of 5. Each of the numbers 5, 10, 15, 20 and so on are multiples of 5. Finding prime numbers. Now let us find out all the prime numbers between 1 and 100. List all numbers from 1 to 100 as shown below. Cross out 1 because it is not a prime number. Encircle 2. Cross out all the multiples of 2 other than 2, that is 4, 6, 8 and so on. The next uncrossed number is 3. Encircle 3 and cross out all the multiples of 3 other than 3. Now the next uncrossed number is 5. Encircle 5 and cross out all the multiples of 5 other than 5. Continue this process till all the numbers in the list are either encircled or crossed out. All the encircled numbers are prime numbers. All the crossed out numbers other than 1 are composite numbers. This method is called the sieve of Eratosthenes. Divisibility tests of numbers. Divisibility by 2. Here are some divisibility tests which let you test if one number is divisible by another without having to do much calculations. A number is divisible by 2 if it ends with any of the digits 0, 2, 4, 6 or 8. For example, 512, 4720 and 368 are divisible by 2. The number 512 has 2 at its units place. So, by the divisibility rule, we say that it is divisible by 2. Also, on dividing 512 by 2, we get the remainder 0. This verifies the rule. The numbers 4720 and 368 are divisible by 2 as their end digits are 0 and 8 respectively. Divisibility by 3. A number is divisible by 3 if the sum of the digits is a multiple of 3. For example, 2, 6, 4 is divisible by 3 as the sum of its digit, that is 12, is divisible by 3. We can verify the rule by dividing 264 215 is not divisible by 3 as the sum of its digits, that is 8, is not divisible by 3. Divisibility by 4. A number with 3 or more digits is divisible by 4 if the number formed by its last two digits, that is, ones and tens, is divisible by 4. For example, 488 is divisible by 4 as its last two digits, that is, 88 is divisible by 4. Similarly, 612 and 740 both are divisible by 4. Note that 1265 is not divisible by 4 as its last two digits, that is 65, is not divisible by 4. Divisibility by 5. A number is divisible by 5 if it has either 0 or 5 in its ones place. For example, 50, 135, 76,895 are all divisible by 5 as they have 0 or 5 in its ones place. We can check this by dividing 76,895 by 5. Divisibility by 6. A number is divisible by 6 if it is divisible by 2 and 3 both. For example, the number 36 is divisible by 2. Also, it is divisible by 3. Therefore, we say that 36 is divisible by 6. Note that 64 is not divisible by 6, as though it is divisible by 2, but it is not divisible by 3. Divisibility by 8. A number with 4 or more digits is divisible by 8 if the number formed by the last 3 digits is divisible by 8. For example, 2416. The number formed by its last 3 digits, that is 416, is divisible by 8. So we say that 2416 is divisible by 8. Divisibility by 9. A number is divisible by 9 if the sum of the digits of the number is divisible by 9. For example, 729. The sum of all its digits of 729 is 18, which is divisible by 9. Therefore, 729 is divisible by 9. Divisibility by 10. A number is divisible by 10 if a number has 0 in the ones place. For example, 20, 7690, 1040, 560 and 2800 are all divisible by 10 as all the numbers have 0 in the ones place. Divisibility by 11. A number is divisible by 11 if the difference between the sum of the digits at odd places from the right and the sum of the digits at even places from the right of the number is either 0 or divisible by 11. For example, consider the number 1,08,064. The sum of the digits at odd places is 4 and the sum of the digits at even places is 15. So we find that the difference is 11. Therefore, 1,08,064 is divisible by 11. Is 8,68,857 divisible by 11? Let's check it out. Sum of the digits at odd places is equal to 7 plus 8 plus 6, which is equal to 21. And that at even places is 5 plus 8 plus 8, which is also equal to 21. So the difference is equal to 0. Hence, 8,68,857 is divisible by 11. Even and odd numbers. Children, here we will learn about the different types of numbers. Let us first recall what are even numbers and odd numbers with the help of a number line. The numbers which are divisible by 2, that is 2, 4, 6, 8 and so on, are called even numbers. The other numbers such as 1, 3, 5, 7, 9 and so on are called odd numbers. Observe that starting from 1, if we skip a number, we get odd numbers. In the same manner, starting from 2, if we skip a number, we get all the even numbers. Prime factorization. The process of finding all the prime factors of a number is called prime factorization. Consider the number 24. We first break 24 into all its factors: 2 into 12, 3 into 8 and 4 into 6. Then we further factorize them as shown. In all the above factorizations of 24, we ultimately arrive at only one factorization. That is 2 into 2 into 2 into 3. This is the prime factorization of 24. We can also find the prime factors of 24 by dividing it by prime numbers 2, 3 and so on in this order repeatedly, so long as the quotient is divisible by that number. We get the prime factorization of 24 as 2 into 2 into 2 into 3. Relationship between Hcf and Lcm of two numbers. The product of Lcm and Hcf of two natural numbers is equal to the product of the numbers. For example, Consider two numbers, 18 and 24. Using factor tree, we find the HCF of the two numbers. We can break 18 into 2 and 9. Further, 9 can be written as 3 into 3. Also, 24 can be written as 3 into 8. Break 8 into 2 and 4. Again, 4 into 2 and 2. So, prime factorization of 18 is 2 into 3 into 3, and that of 24 is 2 into 2 into 2 into 3. Clearly, 2 into 3 is common to both. So, HCF of 18 and 24 is 6. Now we know that the product of two numbers is equal to the product of their LCM and HCF. So, we get 18 into 24 is equal to LCM into 6, or LCM is equal to 18 into 24 whole divided by 6. So, we get LCM of 18 and 24 is 72. Prime and composite numbers. We know that one is divisible by every number. Also, every number is divisible by itself. For example, consider the number 5. 5 is divisible by only two numbers, namely 1 and itself. Similarly, 7 and 11 are divisible by 1 and itself. Such natural numbers which are divisible by 1 and itself only are called prime numbers. Now consider the number 4. Besides 1 and itself, 4 is divisible by 2 also. That is, 4 is divisible by more than two numbers. Similarly, 6 is divisible by 1, 2, 3 and 6. The numbers which are divisible by more than two numbers are called composite numbers. Note that 1 is neither a prime nor a composite number. Also, 2 is the